y-intercept. Austin, you recall how you find a y-intercept for a graph? Correct. Somebody help me out on the y-intercept. Good, so x equals 0. So number 3 is the y-int. Okay, the nice thing about y-intercepts is that if y equals ax squared plus bx plus c, because that's your standard form, what's the y-intercept always going to be? Just c, just a number there, okay? So the y-int is, I'm going to say 0 comma c, right? I'm going to put the 0 in there just because we use coordinates in this class. Now hopefully this should all look somewhat familiar to you from last year. Excuse me. If it doesn't, that's okay. All right, but basically it's just combining the skills we used, excuse me, in the last 2 days. Good. I am a neat freak. I'm not a neat freak at all, but when it comes to graphs, I'm a neat freak. Okay, so there are some certain things I'll be asking that you guys do for your graphs. All right, you will lose marks if you don't do them. Okay, so I'll go through all those right now. Good. Here we go. Example 1. I forgot about that. There are 4 key points. Sorry about that. Why did I only list 3? Where's the 4th hidden point going to be? Yeah, go ahead. Yeah, there's going to be 2 x-intercepts, so that's the 4th point. All right, for that. So sometimes there might only be 2 points, because again, you don't have to have x-intercepts. Did somebody tell me a situation where there wouldn't be an x-intercept? We talked a little bit about this yesterday. Halfway here.
Yeah. Well, like when it opens down and it's in like the negative, like little quadrant.
Good.
So
Very good. I'm going to use a demonstration right now. Imagine me throwing this marker. I can't believe I'm going to do this. Okay? I'm going to try and hit the ceiling. If I don't hit the ceiling, that would mean there'll be no intercepts. I'm not going to hit the ceiling. Don't worry, I don't think. That's it. I caught it too. That's good. Okay. Right. So that's okay. There's no x-intercepts. Does that mean it's not a parabola? No, it's still a parabola. Right? Is there an error? No, there's no error. Just there's no x-intercepts. Okay, and we talked a little bit about that yesterday. Here we go. So example 1. How are we doing for time? Graph the function y equals negative 2x squared plus 4x plus 7 using 4 points. Okay, so what's going to happen is I'm going to take this, I'm going to take you through this for the first one. You guys are going to do the second one yourselves. Okay, and then that'll be it for today's lesson probably. Okay, so we'll do 2 examples, all we got time for today. So I'll go through number 1 with you guys right now, nice and slow and gentle, and then I'll give you guys a chance to try number 2. All right, Owen, I'm picking on you first. What is your favorite point to do, the vertex, the x-intercepts, or the y-intercept? The vertex. Sounds good to me. Okay, so you choose to do the vertex. Okay, Owen, I'm going to start with y equals negative 2x squared plus 4x plus 7. Can you give me the first step, please?
So you would have to complete the square first.
Good.
So it would be y equals.
Yeah.
And then you take it to its side brackets.
Yeah.
And in brackets bx squared.
Yeah.
And then it would be negative 4x. No, just negative 4. Negative 2x.
Good.
And plus.
Now just to make sure, remember, because you're like dividing, but. All right, Adria, what's the next step here now, please? Good. So a little arrow, negative 2 divided by 2 squared, which happens to be negative 1 squared, and then divided by 1. Again, if you did this differently in grade 10, that's fine. All right, I'm doing it this way because, again, all 4 has to fit north south on a piece of paper. Yeah.
On a test, would you ask us to like do a graph a specific way, or just?
If I see using the 4 points method, I want to see vertex and all that, right? Because we'll deal with transformations later on. But yeah, I'll get to that. Yeah. Yeah, it's fine. As far as the vertex goes, as long as you get the vertex, I'm fine with it. Like, as long as you get it in vertex form, either way, it's fine. fine. So if you did like 100 of them last year, I'm not gonna teach you a new way to do it, right? Look, not a big deal. All right, Marissa, what happens now, please? Okay. We're gonna plus and minus it. Great. All right, Luke, what did you do now, please?
You take the negative 1 by multiplying it by
Okay. So y equals negative 2 x squared minus 2x plus 1. Change to plus 2, right? Plus 7, is that right? I think so. All right, Noah, what did you do now, please?
Then you can use the underline number,
Okay.
y equals negative 2.
Yeah, squared plus 9, yeah. All right, Kylie, what's the vertex, please, and which way will this be opening?
So the vertex is 1, 9.
Yeah.
And it
Great. Okay, I'm going to sketch this point right now, okay? The reason it opens downward is Kylie can explain to the class, because I hear some people saying, why is that? Why does that graph open downwards?
the number that you factored out first is negative.
Good. This number right here is going to be negative here, so negative moves downward. Remember we had a little silly face yesterday, right? There's a sad face like that, so that's the problem. Okay, I'm going to graph that first point. I'm not going to do a whole parabola shape, but at least I want to see, because I want to, using the vertex, you help to get a trend where the rest of your points are going to be. So I'm going to take a second here. Now in this class, take a second to do this. You may fit, if you can, 4 graphs on one page, I can live with that. So how you get 4 graphs on one page is you fold the paper like this once, fold the paper like that twice. If you want to fit 2 graphs on one page, that's fine. If you want to fit 1 page on, that's fine, but sort of 4 would be okay with me. So 4 on the front, 4 on the back, that's fine by me. Does that make sense, what I said? If it doesn't, you can make it up however you want. Okay, but that should be enough room. If you might need to change your scale, and that's cool too. Okay, if you count by 2s, or count by 3s, or count by 100s, that's all right. Does anyone need to bore a piece of graph paper? You guys are all friends in here. This is wonderful. Okay, good. I'm going to get rid of the left-hand board. Does everyone see? Everyone's copy that down? Yes? Good? Wonderful. Okay, so as you guys are folding your graph paper, I'm going to fold my graph paper too. Okay? Okay, great. Excellent. Okay, let's talk about the things that I'm picky on for a graph. Number one thing I'm picky on is using a ruler. So you must use a ruler for your straight lines, okay? If you don't have a ruler today, it's one of the requirements in the course. If you don't have a ruler by this weekend, I will call your mother up and tell them to buy you a ruler, okay? Or your father or your whoever you're staying with right now. I'll tell them to buy you a ruler. You need one for this course. I'm going to embarrass you right now, Kylie. As I mentioned before, this is the best ruler in the world. The reason that is that it fits right inside your binder so you'll never lose it. That was always my problem as a teenager too. Okay, I should have one of those pencil cases that went in your binder, so that I always lose my pencil case as well when I was a teenager. That's neither here nor there though. So the point is I'm going to put, draw a line. Now, since I know the vertex at 1 and 9 and opens downward, how can I draw my graph? Like, do I have to put it like right in the middle? Probably not, right? Okay, because there's going to be no actual negative values on here. So I'm probably going to do my graph probably something like this. Okay. All right. Now, Alexander, was something else I should put on this graph before I actually start graphing? Y-axis. X and Y-axis, sounds good. And you will be losing marks if you don't put any of these things on here. Yeah, so sorry, I got a bad move, so I'm not going to be around the bush there. Oops. Great. Really, there's something else I should put on this graph before I plot my first point. Numbers would be good, definitely, okay? There are people who just assume that I can read your minds, okay? can't read your minds. Please put numbers on so I know, okay? So this has to get up to 9 at least. I'm gonna count 1, 2, 3, 4, 5, 6, 7, 8, 9, get to 18. I hope I can. Oh, that's not gonna work, is it? Ah, sugar. That's all right. Luckily I have an eraser. So plan out unlike what your teacher did there. Okay, great. I'm gonna put it this way too. I'm gonna probably leave two because I don't think it's gonna get done. Okay, wonderful, tremendous. All right, I'm gonna skip you, Quinn. I'm gonna come back to you after because there's one thing that Jennifer, I guarantee, knows what else we need to do to this graph before we actually graph it. What else should I put on there, please? Arrows everywhere. Why do I put on arrows on a graph? It's never ending, right? Like, think of this, like I always, nobody did digital cameras there. This is when I started teaching. People had digital cameras, right? The way you could like zoom in and zoom out and like stretch and do things like this. I always use a phone to take selfies nowadays, okay? But the idea is this could go on forever. I just have to take a snapshot right in the middle of this graph, but I could really be doing it anywhere. So we'll put arrows. And again, if you've tried Desmos or anything, any sort of graphing calculator thing, you can easily zoom in and out of things. All right, so now I'm going to plot my point. 1 and 9 is going to be x is 1, y is 9. So it's going to be up here someplace, sort of like that. Now I don't know how wide it's going to be. That's just an estimate there. Okay, as far as like how, I don't know where my roots are. I got to calculate all that stuff. Okay, but because that opens downwards though, I know that I'm going to shed it to the intercepts hopefully here. Just this all come back. Yep. I told you Mr. Lacey told me I could yell at you, right? Just say. Your parents didn't actually give me permission, but other teacher gave me permission. All right, ready? Who do we got here? Quinn, what would you like to find next? The x-intercepts or the y-intercept? Sounds good. So, and you're not done yet. How do you find the x-intercepts? So it's going to be 0 equal, what's the equation? Negative 2x squared plus 4x plus 7. All right. So confirm for me. That's correct. All right. Now here's the little rule that when I make you graph parabolas, there are two options. Option number 1 is that the completing the square is beautiful, like this one is, and then the factoring is quadratic formula. Option number 2 is that it factors beautifully, and then you got the completing the square is messy. So this one had a beautiful completing the square, like with nice integers. 1 and 9 is so nice. All right, so this is giving messy roots, unfortunately. So M and A isn't going to work for this one, right? Multiply negative 14 add 4 doesn't work. So I have to use quadratic formula. Grace, can you recite from memory the quadratic formula, please?
X equals 3 is 3 plus minus square root of b squared minus 4 is 3, all five.
All right, Adam, can you tell me what A equals or B equals and what C equals, please?
A equals negative 2, B equals 4, C equals.
Riley, can you sub that in, please?
Negative 4 plus 9
Okay, now this is the most difficult part of this question, because there will be someone in this class. Call him Tristan, so I'm very nice. That's exactly what the reason is. Okay, Chantal, what is 4 squared, please? No calculator? You can do it. Good. Good, thank you. Okay. How am I going to do this graph here now? Okay, so this is negative 4 plus, I'm going to extend the page, I think. Sorry. Probably the top is gone there if you need it there, okay? All right, so here's the real difficult part. I'm sorry, Julia, even though I'm married to your husband, that's a rumor, your husband to your dad. You're not, you're married. Look at this, I'm all mixed up. You're not married to her. Are we good on this? I'm not, but go ahead. Julia, what is negative 4 times negative 2 times 7, please? Good. Positive or negative? Positive. Okay, now the reason it's positive, and people always get this mixed up, right? That negative carries through, right? So negative 4 times negative 2. I'm sorry for embarrassing that. Sorry. I apologize for that. Oh, parent teacher interview is going to be fun. Okay. Emily, next up, please, is what?
60 to 56.
Right. So I'm going to say x equals negative 4 plus the root of 72 all over negative 4, or x equals negative 4 minus the square of 72. All right, Brad, calculate time. Square of 72 is what?
8.49.
8.49. I'm assuming there's more decimals, and you'll keep those, of course. On your calculator. This is the biggest example ever, that's all right. So here's going to be x equals negative 4 minus. Great. Who do we have to? Cole, back to you. Give you the little 2 roots, please. It's going to be what? Okay. 3 point ouch. 3.1, 3.121? 3.121. Everyone's confirmed we're good? Okay, now here's the thing I want you guys to write, because I don't know why this bugs me. Somebody's going to tell me that, therefore, the next point on the graph is going to be negative 1.21, comma 3.12, which is totally incorrect. What are the points that I've actually found here? Luke, go ahead. Yeah, good. So what's the y value going to be for both those? 0. So I got you to write here, and yes, I'm neat about that. Okay, put the actual points there, because somebody's going to tell me the points in the middle there, right? Which is fine. So negative 1.21, 0 is going to be over here someplace, and 3.12 is going to be over here someplace. And that looks, if you take a look, negative 1 looks to be pretty close to being, sorry, 1 looks to be fairly close to being in the middle. So good. Just coming back. Over left. Kristen, to finish off, what's my last point going to be? Good.
Y-intercept.
Y-intercept, how do you get the y-intercept?
Yes, x is 0.
And I'll do this one now. So y is going to be, what was it for negative 2x squared plus 4x plus that. So it's going to be 0. There's a nice, beautiful, happy parabola right there. I used to make my classes, and when I talk about it, I tend to do this. What's the symmetrical point on the right-hand side? So 0, 7. What's the corresponding point going to be on the other side? Sorry? 2, 7, exactly. Because if you take a look, right, if you think your axis symmetry goes like this, so it should be mirrored, it should go the one this way. This one's an optional point, I didn't put that in there, but just to help to make your graph look good, you put that in. All right, so I'm going to connect the dots and leave the graph like this. Is that right? I actually missed my 2. Oh. Let's try again. 2, 7 should be here. That's better. All right, Marissa, I'm picking on you since you're sitting in the back row. Almost. course, I'm not happy with this graph, because I forgot two things. Can you tell me what two things I forgot for this graph? Arrows on the end, okay? So there'll be people in this class that leave the graph like this. Please don't do that. This graph continues on infinitely, and we'll talk about that starting tomorrow, okay? So that'll continue on forever. All right? There's one last thing. Probably I'm picking on you since you're seeing it at the back too. What's the last thing I need for this graph? No, not until tomorrow. Don't scare them. Okay? Yeah, the title will be there somewhere, okay? So you can do whatever sort of title you want. For me, I'll just do one, but I'm glad you're thinking main range, that's good. Okay, that'll be coming up though. Okay. Is this sort of coming back? Yeah, I was good.
In this event, Travis probably just did the step properly. Sorry, we just did the step properly.
Yeah, no. That's a little. Well, because it's not property, you have to do this. Sorry. Good morning. Good afternoon. Good afternoon. Yes. 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 Adrian. Okay, so the thing about the step thing, the reason I don't do the step thing always, because that only works if you have nice integers, right? So when I get to my graphs here, like this, I start off the beautiful, soft, fuzzy, warm parabola here, okay? But if you're trying to graph like -3/5 x this, it's going to be a little bit trickier to do, right? So it's the same idea though, right? So roots and all that stuff. All right, questions, fears about that? No? You guys are good? Sort of good? Wonderful. Tremendous. Okay. I'm actually feeling exhausted. I tell you guys my kid is up at 4 a.m. So I'm going to stop talking right now and just give you guys your homework. It's not out of the textbook. Okay, these are just here right now. If you need one-on-one help on one of these, that's okay. All right, I come down and help, but I'm very tired to talk about it, okay, so I'm not going to do that. Your homework for tonight is going to be 5 graphs. We'll do 4 for you guys. We'll do 4. We'll cut it down to 4. Alright, so we'll do 4. 4 questions for homework, 4 graphs. It's 1 piece of paper. Alright. I want to make sure that when I say graph a parabola like this is just, yeah, I got it, bam, 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 boom, it's done. Okay, right? And I may not be yet, because it's been a while. Like you did transformation, that's the only way you graph in grade 10, which some of you might have, it sounds like. These are good skills to know. But don't worry, we'll be talking about transformations a lot as we continue on. Okay, Jennifer, this all come back? Okay. Okay, I'm going to stop talking. If you guys can get started if you want, you should really get through one of those right now in class, I would hope. Okay, in the next 15 minutes. Stop talking. Sorry, I got to pause. Sorry, we're pausing.